Hello friends, welcome back to my channel Tends to Math, Do Math, Not Myth. In today's lesson, we learn about the previous year questions of JEE Main, which is very helpful for the upcoming JEE Mains exam. So, let's move on to today's topic. Today, we solve the previous year paper of JEE Main, and this is the paper of 9th April 2016. So, let's start with the first question. A value of theta for which 2 plus 3i sin theta by 1 minus 2i sin theta is purely imaginary. Here we find the value of theta from this given form, and here the given options are sin inverse 1 by root 3, pi by 3, pi by 6 and sin inverse root 3 by 4. So, from this given form 2 plus 3i sin theta by 1 minus 2i sin theta, we find the value of theta. First, we multiplying the conjugate part, that is 1 plus 2i sin theta, with the denominator and with the numerator and denominator. Okay. Then we get 2 plus 4i sin theta plus 3i sin theta plus 6i square sin square theta by 1 square minus 2i sin theta whole square. Okay. 2 plus 4i sin theta plus 3i sin theta, and we know that the value of I square is minus 1, so we get minus 6 sin square theta by 1 plus 4 sin square theta. Okay. Next, 2 minus 6 sin square theta plus 7i sin theta by 1 plus 4 sin square theta. Note down this portion. Okay. So, we get the term 2 minus 6 sin square theta plus 7i sin theta by 1 plus 4 sin square theta. Since we have to make this term purely imaginary, so here the imaginary part is 2 minus 6 sin square theta by 1 plus 4 sin square theta plus I into 7 sin theta by 1 plus 4 sin square theta. Okay. Here the real part is, this is the real part and this is the imaginary part. Okay. Since we have to make this term purely imaginary, so we have to equate this term with 0. 2 minus 6 sin square theta by 1 plus 4 sin theta equal to 0. We get 2 minus 6 sin square theta equal to 0, sin square theta equal to 1 by 3, sin theta equal to plus minus 1 by root 3, and theta equal to plus minus sin inverse 1 by root 3. Okay. So here the values of theta is either sin inverse 1 by root 3 or minus sin inverse 1 by root 3. And from the given option we can find here the first option is sin inverse 1 by root 3, which is equal to the which is equal to our answer. So here the option is, here the option A is the right answer. Okay, please note down this portion. Our next question is the system of linear equations x plus lambda y minus z equal to 0, lambda x minus y minus z equal to 0, x plus y minus lambda z equal to 0 has a non-trivial solution for option number 1 exactly 3 values of lambda, in option number 2 infinitely many values of lambda, option number 3 exactly 1 values of lambda, and option number 4 exactly 2 values of lambda. Here 3 sets of equations are given. We have to find the values of lambda which is non-trivial. So what is trivial solution and what is non-trivial solution? Trivial solution is always equal to 0. A solution which is equal to 0, this is called trivial solutions. And non-trivial solution means if we can find 2 or 3 values of lambda, then within these 3 value or 2 values of lambda, at least one of the values is non-zero. Okay, if we can get lambda equal to 1, 0. Okay, here 0 is the trivial solution, but for the presence of 1, these solutions are called non-trivial solution. Okay, now let's find the values of lambda. Here we make this determinant with the coefficient of xyz. Here in the first equation the coefficient of xyz is 1 lambda minus 1, next lambda minus 1 and 1 1 minus lambda equal to 0. Now expand this determinant, we get 1 lambda plus 1 minus lambda square plus 1 and minus 1 lambda plus 1 equal to 0. Okay. Next we get lambda plus 1 plus lambda cube minus lambda minus 1 equal to 0. That is, cancel out lambda cube and cancel out also 1, lambda cube minus lambda equal to 0. Okay. Next this is the common term, here the common part is lambda. So we get lambda into lambda square minus 1 equal to 0. So here the solutions of lambda equal to 0 or lambda equal to plus minus 1. So here we can get 3 solutions of lambda, 0, 1 and minus 1. Since 1 and minus 1 are the non-zero roots of lambda, so we can say that these are non-trivial solution. So here non-trivial solution is 3, 0, plus 1 and minus 1. So exactly 3 values of lambda. This system of solution has a non-trivial solution, or this system has a non-trivial solution. Okay, please note down it. Here the third question is, a wire of length 2 unit is cut into 2 parts which are bent respectively in form a square of side x unit and a circle of radius r unit. If the sum of the area of the square and the circle is formed is minimum, then which relation is occurred? Option number 1 2x minus r, option number 2 2x equal to pi by 4 into r, option number 3 4 minus pi into x equal to pi r, and option number 4 x equal to 2r. Okay, let's start. A wire of length 2 units is cut into 2 parts. one part is a square and the other part is a circle. Okay. And here the length of the side of square is x unit. And other part is a circle whose radius is r unit. Okay. Next, the perimeter of the square is 4x and the circumference of the circle is the perimeter of the square is 4x and the circumference of the circle is 2 pi r. Since these two shapes are made with the length of 2 units, the length of wire of 2 units, so therefore the sum of the perimeter of the square and also the circumference of the circle is equal to 2. Then we get 2 pi r equal to 2 minus 4x, r equal to 2 minus 4x by 2 pi. Okay. Now we have to minimize the term that the sum of the areas of square and the circle. Let us take A equal to the sum of the area of square and the circle. The sum of the area of square is x square and the area of circle is pi r square. Okay. Here the value of r is 2 minus 4x by 2 pi whole square. We get x square plus pi by 4 pi square into 2 minus 4x whole square. Then differentiating both sides with respect to x, we get dA by dx equal to 2x plus 1 by 4 pi into 2 into 2 minus 4x into minus 4. Okay. Next, we get that dA by dx equal to 2x plus 1 by 2 pi minus 4 into 2 minus 4x. For any maximum or minimum values of A, dA by dx equal to 0. So, if we equate the term dA dx equal to 0, then we get 2x minus 4 by pi plus 8 by pi x equal to 0. That is 2 plus 8 by pi equal to 4 by pi. X equal to 4 by pi by 2 into 1 plus 4 by pi. Then we get x equal to 4 by 2 into pi plus 4, that is x equal to 2 by pi plus 4. Okay. Note down it. Next we have to find d2a dx2 from dA by dx. So here the term dA by dx equal to 2x minus 2 by pi 2 minus 4x. So d2a dx2 equal to 2 minus 2 by pi into minus 4, that is 2 plus 8 by pi. Okay. we have to find from there x equal to 2 by pi plus 4. So the value of d2a dx2 at x equal to 2 by pi plus 4 is 2 plus 8 by pi, which is greater than 0. Then we can say that at the value x equal to 2 by pi plus 4, the sum of the area of square and the circle is minimum. Okay. Next, we have to put the value of x at our first equation is 4x plus 2 pi r equal to 2. If we put the term x 2 by pi plus 4 plus 2 pi r equal to 2, then we get 4 by pi plus 4 plus pi r equal to 1, pi r equal to 1 minus 4 by pi plus 4, that is pi r equal to pi plus 4 minus 4 r equal to we get 1 by pi plus 4, and here x equal to we get 2 by pi plus 4. So the relation between these two equation is x equal to 2r. Okay, and here the option number 4 is the right answer, that is x equal to 2r. Hope you guys like this video. If you like my video, then please subscribe my channel and hit the bell icon for getting more updates, and share this video with your friends. Take care and goodbye.